Nice that you've chosen my talk. Great, thank you. Okay, so I don't have much time. I will not talk about me, but I will talk about the title of the presentation. Actually, the original title of a presentation should be like this, but you have seen it written a little bit differently, with some dashes in front. Some people asked me, what language is that, because it doesn't compile perfectly in a brainfuck. And so I will explain you that, because there was an email I sent like a month ago to Paulina with details of the presentation, and you see there is like a version of a Polish version and English version, and this English version starts with these dashes. I wanted to separate it, but I didn't know one thing. Paulina is a developer. She already worked with business, and she knew that if you work with business, you just do what they say, no matter how stupid it looks like. So she simply took it as a title, and I can't really blame, because it's exactly as I written that. So actually, in order to somehow cover this problem, I changed the title of the presentation, and it's like this. And it doesn't really compile, but okay, we have to live with that. Okay, but after the talk, one thing, there's instruction, there is like inventory application, and I hope you see this, what you have to do. Press this 5 number there. No, not 4, not 3, not 2, no, don't try this. I need an honest feedback, okay? Okay, this presentation started because I'm quite active on a for programmers .NET page, which is, some people call it Polish Stack Overflow. It's not really Stack Overflow because it's not question and technical answer. If you have a question, it's a great page to post it. The Java part is quite active. You will get answers. If you know how to answer questions, you can really help people. That's great. And you can learn how to help people better. But this page has something else. This is a community. There are topics like career, problems with community problems of topics, etc. And quite regularly, apart from this technical stuff, the technical questions, comes something we call typical drama post, like 2-4 times each month. And I think in summer more often, so maybe it's more in winter less, but more. This is in Polish, how it looks like. Most of you can read it, but in English, let's sum it up, that why do we always have these new technologies in IT? Why do I have to learn this? Why do I have to learn new frameworks, new programming language? Can't I just learn once and work with that till retirement? I don't have time. Because of these things, crazy things in IT, I don't have time for girls, for family, for hobbies. This is horrible. We have to change that. Does it even end? So all that problems. And that's actual problem. A lot of people have that problem. I wasn't aware like 20 years ago that this is, for some people, a problem. And okay, so knowing that, I have a question to you. Your first programming language that you've learned. And everybody knows the first programming language? Can you shout it right now? Shout your first programming language, loud. Yeah, great. Did I hear Pascal? Of course, like, my first programming language was a little bit worse than Pascal. So, sorry. Sorry. My first You've seen the joke. That was my first programming language, no, not the Pascal. And of course, that was basic, horrible. But you have a favorite language, of course. And I already shown you which one is this, but let's sum it up. You know it well, you like it, and this is very important for each community. You don't like others. No, that's how you form the community, your religion, yeah? And you can do everything in it, and you would love to. And shout this name of this language, please. Oh, come on, I really knew that. It's really no shame. I also did some PHP. I loved it. Okay, so there is a great page that I take inspiration sometimes. This is called 99 Bottles of Beer. It's one simple algorithm. Writing this song, it's actually very long. This is only the initial part. Write the code printing that. in any language you want. And you will see some crazy solutions like Java, extremely object-oriented programming, Java, I think even maybe, right now it's time to do it Java with annotations only. Try to. I think there is not yet done. And only in C, preprocessor directives, etc., etc. So this is a really crazy page to see how people solve the problem, simple problem. And there are other pages like this. So this is how you can find really crazy languages. And I like to do that. But before, this is just fun. Now let's explain how we have all this 1,500 languages. Actually, we have way, way more. So let's talk about hardware and how it started. You know what is considered kind of a first computer? Who knows? Shout it! Odra. Okay. So this is not an easy topic. First computer kind of can be considered that. You know when it was created? Okay. Actually, more or less, 19th century, actually it wasn't created. It was designed, it was planned. The thing is, it was like, you know, the dream of a steampunk people. This was computer with gears, powered by steam, with all of that stuff, totally mechanical. Unfortunately, the design was kind of okay, but the precision of the machines at that time didn't really allow it to run, and basically it was never finished. And even now, it's a challenge, technical engineering challenge to finish it, but as far as I know, it was already, some people already recreated this computer, at least some parts. I don't really know if it already works. But it was 21st century when they first started to realize it. Okay, and this computer already had some kind of a programming. Actually, it was designed as a better programmable calculator, but because of that, it had some programming things, but this programming looked differently. I've seen this as a representation how the first programs could look like. Actually, you can even find in Google the materials. Actually, the first program more looked like a description with diagrams, etc., how it should, because, come on, they didn't have ASCII files with a steam engine, etc., and they didn't have other stuff, so this is only representation. And you know who is this? Great that you know that she is considered the first software developer. That's great, and she was involved in that all stuff. Although, quite honestly, talking about programming and who did what at that time, that's a complex story. It's a really complex story behind. So, but I don't have time for that. Let's switch for something completely else. We now have a hardware part. It was already possible to do something in 19th century. We need this programming language, real one. And actually, first programming language that I consider a programming language because I can work with that, I can program in that. You know what is this? What? Haskell, okay. I didn't even know. Okay, I didn't, it's not real Haskell. It's lambda calculus by mathematical definition. And actually, there are pages you can run this code online and test it. And this is like a real example of a code. And the lambda calculus, it was created in 1930 by Church. And this, in fact, it wasn't designed to be a programming language. It was designed to be a language for mathematicians to describe algorithms. And it is great because it's minimal, it's a low-level language of mathematics. And by accident, it can be used to program computer. And it's even called Turing Tarpit. If you don't know what it is, it's a funny term to describe a language that you can potentially program something, but it's extremely hard because it's very minimal. And I love this language because it's like, it needs no computer to run. You can do it on paper. So we had, at the, let's say 1930, we have both components. We had hardware, we have languages, like a spirit, something that we can put together, and it was a time to start with computers, real ones. And what is the next computer you would name? No. That is, if you should take something from the lesson, this is a more complex story. Actually, those guys in States created in 1933 something that could be considered computer, it's electromechanical. It's no more uses steam and whatever for power. It uses electricity, but it has a lot of mechanical parts, so it's a very noisy machine. And actually, there was a card, and they were granted patent for a computer, kind of, and because previously ENIAC was considered, but in 60s they won, that they are actual authors of the first computer. And in the meantime, there was something else. Who ever heard about this? Who? Just raise your hand. This is something that everybody in Germany will tell you. We had the first computer. Konrad Zuse created that. You see, the date was very unfortunate to spread this. But yes, indeed, this machine was considered like computer. It had some limitation, but it is. And it was very, after the Second World War, it was quite not politically correct to assume that one of the most important computers were created, in Germany during the Second World War. And actually, the more important, Konrad Zuse, he created something which is considered first high-level programming language, but again, partially for political reasons, it was just ignored and didn't play any role, so we will not discuss it. It's up to you to find this language. It's quite interesting because it doesn't look as anything you know. Okay, and then we had Colossus, ENIAC, etc., etc. This story later is quite known, of course, and that's how programming looked like at the beginning. So those were software developers switching stuff, plugging cables. That was a programming. There were no ASCII files to write something. You had to walk along a lot to program those machines. That was like an exercise. And it was done by women. You see, if you look at the pictures from that time, you will see a lot of women involved in programming. That was completely, I would say, normal, and that was, I would say, default, that would be done by women because they were good at it. That was the job of a software developer. I don't know how could it have changed, because I see completely different ratio of women to men right now. But okay, if you look at this picture, this is something you instantly see. And this programming with switches could be represented by some language. I will now present something that doesn't come from ENIAC, but it is like 30 years later, but it more or less shows what the ladies and people were doing with those switches. And you should completely understand what's written here. You know what language is this? Of course, this is machine language. Of course, but this is easy, what it does. Okay, that would be hard. Now let me make it easy for you. It's for a processor called 6510. That's easy then, okay? No, come on. And you have to put it in the memory address like this. And now it should be obvious. No, come on. This is, of course, Fibonacci. You see it because you know that F0 is a conditional branch, etc., etc. So this is really, like 20 years ago, I knew people that could read that. And honestly, I still know some of them, because that's how we programmed before we got the good tools for that. But okay, machine code. That was a language of the machines, and it's actually simple to learn. We have opcodes, but on that time there were not that many. First machines had like 10, 20 opcodes. So it was easy to find out how to work with that. The problem is that calculating these conditional loops, so I jump, but how many bytes? And what if I want to extend it later, etc., etc. That was very boring and tedious job. And even though the language actually is very simple, contrary to what people say, that's one of the simplest language you can learn. But it's hard to program anything meaningful in that. It's just like this. So the people needed something more sophisticated, and they created really something great. You know what that is, of course. That's the same program. Now it's obvious. Assembly, and it's the same program in assembly, so now it's readable. Everybody can read that. And of course, you see this Fibonacci. Some people should instantly say that it's completely unoptimal. I'm wasting 2 cycles for each calculation. This is really horrible code. I don't recommend writing like that. Those waste of 2 cycles per each loop is horrible. Okay, that was designed like 1949. And, for noobs that couldn't really remember all those opcodes and calculate, obviously. And Assembly, actually, well, of course, it was great because it was as fast as machine language. And it had some portability, actually. If you say assembly is not portable, there were, in history, a lot of important projects were ported in assembly from one architecture to another, with search and replace and some very easy adaptations. It was kind of portable. And of course, still you had registers hell, so in assembly you don't have variables, you have like 3 registers, and you have to always remember, oh, I have a loop count in in X register, I have to not forget to replace it accidentally or override with something. This is a hell. And everything is great, but arithmetic calculations are horrible, and in the assembly you really need to comment this code. You've seen a lot of comments there. If you see assembly, you have to comment it. Lot of lines. So that's how it started with commenting. Okay. But meanwhile, however, we had this mechanical, electromechanical computers. It was changing a little bit. And we had this. You know what is this? It looks like something from NASA or whatever. What is this? This is a memory, Delay Lane memory, Mercury memory. This is the most crazy memory you can imagine. I won't explain you how it works, but you should be really careful walking around those devices, because if you stamped too heavy, that would destroy this memory. You couldn't be angry around this. So you had to be very patient while programming. Okay, so because of this more memory, we could use other languages. What is this? This should be easy for you. We have if statements, that's invention. We have goto. Yeah, this is Fortran. What's the difference between Fortran and Basic? Because in Fortran, line numbers actually do not have to be in order. Like, sorry, I'm on the wrong screen, but if you look here, you would see that there is line 9,000 and then 3,502. So basically those numbers were more labels than real numbers of the lines. And that was a Fortran. And why was Fortran great? Because it was no more just assembly. It allowed to write arithmetic, but it was still very close to assembly. Like goto was a jump instruction, etc. If was like a branch. And it had very crazy type system, because that's what I love about this language, pragmatical. If the variable started with I, N, J, K, L, it means it was kind of index, like mathematicians use. So it must be integer, otherwise it's float. You know, it's great, it's pragmatic. Of course, it still had a go to hell, and it was great language for mathematicians. So if you have a mathematical algorithm, writing it down to Fortran was quite straightforward, partially through the choices like this design of a type system and naming. But okay, mathematicians were kind of served, they had their language. What about people that just wanted to do a business, and they were not like scientists, not mathematicians? And they had a language, and this lady helped them. Who knows who is she? Of course, and what the language is this, what I'm talking? Cobol, although she actually created one language before Cobol, but it's totally forgotten, and this is Cobol. What's great about Cobol? Yeah, this is like Fortran for mathematician, Cobol is for business. And the great thing about Cobol, like, just look at this. Just look at the beauty of the Cobol that, for instance, as you see, move first number to display number. Display it reads as an English. It's perfectly readable language. I would say this is a language that needs no comments, because code is self-commenting. It's just exactly that's what's written. Come on, no, writing comments in Cobol makes no sense. And yeah, it was extremely fast as Fortran, so it is translation from a language, high-level language to the code, a machine code was easy. And unfortunately, there was one problem with Cobol. It needed extreme ceremony. If you think Java is bloated, you have to write a lot of things. Try for one day coding something simple in Cobol. That would be like amazing. Then you would say, oh my God, Java is all one-liners. Okay. Let's stop about Cobol. First reasons why we create languages, and it was seen at the beginning. We want to just automate simple stuff that can be easily calculated, and we can be more efficient. That's really easy. That's obvious, of course. But while those languages were evolving, we had some changes in the hardware meanwhile. And for instance, Fortran were written in these punch cards. I've seen them. I have never programmed like this, but I actually seen those cards. That's really nice to see programs. And in the meantime, the mechanical parts of the computer were replaced by vacuum tubes. So it was now all electricity. It was not as noisy as before, and the computers were faster. And you know what happened? Because we have the better hardware, we could use that, and we could create another language that would be a little bit farther from the hardware. And this was, sorry, not this. Whoops. Oh, I will do switching on this machine because it doesn't work as expected. Okay, this another language looks like this. And this is, of course, because it was visible. And the problem is, I will not talk about Lisp. Why? Because it needs completely other talk. This is very beautiful language that comes exactly on this picture. Each 10 years, we are rediscovering Lisp. And at the end of the talk, I will refer to that. But Lisp was so far away from the hardware that it was kind of ignored. But it shows an important reason. The hardware is better, we can now try completely new ideas that were previously impossible because the hardware was too limited. And actually, yeah, the code in Lisp is really smart. It was used in artificial intelligence at that time, and this is it. So, but again, mathematicians had the language, business had the language, crazy people had the language, but computer scientists didn't have. And they created what? No, another language, this one, not the Pascal. What? Of course, this is Algol, algorithmic language. And this looks kind of like Pascal, so Algol, I have to be quick about it, but this was really language that if you read old books about algorithms, you see Algol everywhere. Algorithms written in Algol, so they typically say that this is kind of a pseudocode, but it's actually looking like Algol. So it really played an important role. I still have those books. And yeah, today I would say Python plays this role of writing pseudocode that almost works, or works. So this was Python of that time. And 58 was a little better. Fortran 60 was the really dominating, and 68 was great disaster. That is really interesting story. By the way, who knows this man or boy test? Simply, Algol for the first time introduced to the business, to the computing, real recursion. And the test was, and this is an interesting story because some people didn't want to have this recursion because it made compiler really complex, but some people backdoored into the specification of Algol 60, the recursion, and they were then happy. Yeah, we did it, and nobody noticed the paragraph, and now the compilers had to provide recursion. And this was a test done by Donald Knuth if the compiler, this is a real program that you could run and check if your Algol is really behaving well as specified. So like AC test we have for CSS or HTML. And Algol 68 is a funny story. Now Algol was dominating and everybody decided we need Algol ++, better Algol. Ultimate Algol. And you gather 20 best brains of that time and design something great. And because those are really greatest brain, each of them has his own ideas, and they put all of them together. And they created what? Algol 6, not Scala yet, but Algol 68. And actually, this is really crazy good language, way ahead of the time, but it has, for instance, used so many operators. Remember, year 68. And you would have in a language all these operators on keyboard. The problem is, the keyboard at that time looked like this. You were happy if you had more than 24 keys and a space. So it was like, it really missed the reality check. So it took a couple of years to create the first compiler for Algol 68. And actually, Partially this is good, because people seen this disaster, and even before it happened, they tried to solve it somehow. They proposed alternative. Otherwise, we would be programming Algol. Okay, so, but in a hardware this happened. Who knows what this is? This is memory, and I love it, this memory, because this is the last memory when you can see each bit with your own eye, naked eye. Just see. Those are very small pieces, but you can see. And this was at that time a huge amount of memory. And that, of course, you should know that. This is a transistor, the first one working. And this made a revolution. We could now put a more memory and miniaturize all the stuff. And it caused explosion in the hardware and explosion in the languages. And it was like happening at the end of 60s. And this language, for instance, appeared. It's very hard to find out what's this, but it has one important thing that could help you to recognize it, this. So this language is alternative to Algol 68. It's called Algol W, and created by those two guys. And the one said, this null, this put into the language, which then somehow survived next 40 years, was his $1 billion mistake. So thank you, Tony. Okay. And then, of course, we needed another programming language. What is this? I only put this because it is like grandfather and grandfather of Java. This is language that's called BCPL, and it was before C. And so it's something that designers of C looked at, and they wanted to make it a little bit better. But they, in fact, inherited a lot of things, and so this is BCPL. Funny thing, this language had only one type. So actually the thing that if the machine was like 16-bit, it had one type that was like kind of integer, but you could interpret it as a pointer to string or character, whatever. It was just one word. That's one type we have, and because of that we needed Hungarian notation. Thank you, thank you. That was a great thing, Hungarian notation. And whenever I see it in modern code, I love it, because it really misses the point. But then we had this. This is important language. What is this? Of course, BASIC. And what purpose BASIC served? Why do we have BASIC? Because this was like programming now available for masses. Before we had for technicians, for business, for people having a lot of money, for computer science, but now everybody could program. And they had a BASIC. And it was extremely successful language. One of the greatest things in BASIC, it had interpreters. So it means you can kind of a debug, work with your program. You didn't have to compile and wait one day until it compiles and see compilation error. You could see it almost instantly. And that was really great, but of course you know the problems of BASIC, hopefully. That was my first language I learned. And of course, in the meantime, the BASIC was slowly taking over the world. I covered this story a little bit. We had a change in the hardware. This is the memory almost as we now have today. Of course, at the beginning so we had chips, microchips. And that was Intel, one of the first processors, total disaster. Really, designing, this processor was so bad that designing exactly same architecture for a machine language perspective with transistors was actually faster than this. It really happened. So Intel had a problem. They had a crappy processor. They put a lot of money, and no one wanted to use it. So they fixed it a little bit. They created that, and that's a grandfather of your processors you have right now. It is really like line, and all the problems you have with Intel, this extremely complex architecture, legacy architecture, is because it started really at 70s. But this processor was put into this machine, and I love this machine because it's, you know, whom can you associate with this machine? Whom? No. I mean real geniuses. Those ones, of course, Bill Gates. Those were software developers, and actually they programmed BASIC for this machine, not having access to it, having only a crappy documentation. And they created, they put it on a tape, they programmed it on a tape, and then they flight to the provider, to the vendor of this machine, and it worked for the first time, at the first run. Wow, that's amazing. By the way, it was code in assembly language, not having access to the real hardware. They were really great. And they made after this BASIC worked, it was a great success. Everybody wanted to have a BASIC. For instance, a Commodore company which started producing microcomputers. And for instance, Microsoft offered Commodore, we'll create for you our great BASIC if you just sell it with each Commodore computer for $3. We get $3 for each sold computer, and you have BASIC. That's a fair deal, don't you think? But the problem is that problem is that you had a clash between young software developer completely not thinking about the business. He's really a genius coder, and the old Polish businessman, okay, Polish roots, he was actually Jewish. He survived German death camps, and he created his business from scratch in States, and he is a real genius. And the problem is, this clash could have ended only one thing. The negotiation ended totally horrible for Microsoft. Of course, they were offered $25K, but for support for all the basics in all machines till end of the world in the Commodore. So if you find that Commodore sold 20 millions of Commodore 64 and few millions of other computers, you see that the original deal of Bill Gates was actually way better for him. And actually, this deal was so bad that Microsoft almost bankrupted, as they say, because they had to provide updates and everything for this one time paid 25K. And Bill Gates was even so angry that he put in a machine code in one of the updates, Easter egg. You can even try it online with Commodore PET. If you put some sentence on the screen, you would see Microsoft with exclamation. That was like revenge of the Bill Gates, really. And later it was found. Actually, and by the way, I love reading this code. You see really genius code, really. Bill Gates code, when you see how they saved just 5 bytes with some trick in assembly, that's a great thing. Okay, so that was era of BASIC, and this guy came. Really, oops, stop. I have a problem with machinery. I have to switch a little bit. Okay, you see my presentation, but let's go. This guy, okay? Dijkstra, and he said Goto is considered harmful. That was, when I first seen this, of course not at that time, but later I was like, what the hell, I'm always programming with Goto. It's not possible to program without Goto, and that's actually what people said at that time. It's impossible, so I was like, what? And he said, in programming with Goto, you got only spaghetti code, so what the hell? So I was really quite angry when I seen that, but he said, you should do structural programming, and he proposed this language. Yeah, you know what is this. Now it's easy. Okay, not him. Other guy, they actually knew each other, that was Niklas Wirth. What was this? Pascal, of course. And of course, in Pascal, you have no Goto. That's the proof. It works. Variables must be declared. Structural programming was introduced. And so there is a very important reasons why you create new languages. You want less bugs. You want to spare yourself Goto hell and all the other problems. Of course. So it also means that, wait, really my machine, I have to switch to this because it spoils my presentation. Structural programming makes spaghetti code impossible, yeah? Everybody knows that. We know that. Yeah, and some people said there is a better alternative. You know what is this? Instruction. If Goto is bad, we have instruction come from. You don't jump somewhere, you say, someone jumped here. Well, that was really a nice idea, and they created another language, this one. This is called interpolate. It is one of the first, if not the first, esoteric language created just for fun, to prove something. And it works. This is really nice idea. But, okay, we will talk more about serious languages. So, meanwhile, we had these hard disks, and we had more space for more sophisticated compilers and stuff like that. So, people created another programming language to use that. And, of course, you know what is this. C. And C was great. OS programming support. By the way, one thing, people often say that C is great because this is the only language you can create operating system. And one thing, There is nothing in C that supports creating operating system. There is nothing like interruption handling. There is nothing like changing the ring, security ring, and everything in a kernel. There is nothing. All of that stuff is built into compilers like pragma directives, etc. It's possible to write this for any other language, including Java, but mostly it's stupid because it was once done for C. Now, if you do for any architecture, you can see how it was done, and that's how somehow, partially accidentally, C became a language of programming operating systems, although actually there are operating systems, of course, written in other languages, and people even now create them. Okay, but of course C had a problem like void start, and of course malloc, and encapsulation. Actually, you have encapsulation in C. This is a really interesting story, but it is kind of unfriendly. But people wanted to solve this problem. They created object-oriented programming in this language, which, for instance, this is sorting, and it uses functions. This is also functional language. What is this? This is C++, of course. And this is a great language, I would say the Scala of that times. And it has almost everything, but still, it has this new delete, and you have to care about memory on your own. And it has meta-programming, and the security is not really existing. So if you are in a bank and you incorporate a library in C, especially in binary, you have to really trust those people there. Okay, but this is the C, and in the meantime, the hardware was changing. Oops. And we had this, the network, the internet. And internet needed a language. And of course, now you know which language was created. That should be familiar to you. Especially this while has more elements, custom object to string and all of that. You know what is this? What? No, that's Java. That is the Java at the time I've the first time seen it. And I was a C++ programmer, and my question was who would really program in that? It had no generics, nothing. It was nothing there compared to C++, really crazy. But of course it had garbage collection, it has this great portability. But if you think that Java was so great, try to code in this Java for one day. And you will think those people were crazy at year 2000, choosing Java, because this language was horrible. Okay, but why did Java won? What was the reason? It was for free. Really, I was then programming my first programs, and C++ compilers costed incredible money for me. I couldn't afford them. Companies in Poland couldn't afford them. And everywhere, young developers couldn't afford professional C++ compiler or something else. They all were for money. There were free compilers, but they were limited. For instance, doing desktop software with that was kind of impossible. So Java was for free, and that was partially why it really succeeded. Of course, please remember to put this. And now the most successful language. We are slowly coming to the end. I think I will extend the time a little bit, but you know this language. That should be easy to recognize. You work. That's JavaScript. That's actually compiling JavaScript. There is a great page called JSFAQ. You put any valid JavaScript that you create, and it recreates another JavaScript that looks like this. And you can use it. And actually, it has uses, for instance, if you have some security preventions, firewalls that prevent for inserting some scripts in a forms, you can avoid them putting code like that. And actually, people use that to breach security. Of course, the guy that he created, he is guilty of creating JavaScript. I will not call him by name. And by the way, JavaScript in the core is really beautiful language. It's kind of a Lisp returning. But the problem is the guy really had a great idea, but he had to, somehow he listened to the business people who told him, okay, you can have it, but you have to use C syntax, like Java or whatever. And that created a monster, really. And I could say, this is a wasted chance. We could have a Lisp in the browser that everybody would love, but we have Frankenstein. Okay, but there is a niche, there is a next reason for the new languages. you need to program things like coffee machine, browser, and we have a special designed languages for that. Okay, so now about types of languages, because we have to slowly end this presentation. If we are categorizing our languages, there are three things we see. For instance, scripting languages versus compiling. Scripting are fast in doing something, compiling are preventing us from doing errors. And you choose. Maybe you want to do something quickly, fast, prototype something, or you doing like project for 2 years and you need more security. You choose. Or you have dynamically typed. Mostly scripting languages and dynamically typed are serve the same purpose, doing something fast, not caring, having things done. And statically typed, you need more security because, I don't know, 20 people will be touching this code. And there is, for instance, one crazy, not many people know what is the difference between statically typed and strongly typed and weakly typed. Actually, there are languages that are statically typed and weak. For instance, C. You have a compiler, this is statically typed in a compilation, but still, you can have a pointer to string and change it to integer, because in the runtime, it doesn't happen. In Java, you can cast integer to object, but you can't in a runtime cast it back to string, because it would fail. Okay, so that's this difference. And by the way, there's a nice discussion. Why do we even care about this? Because one guy, for instance, why do we just make it things ourselves easy with dynamically typed, etc.? This guy posted once on a Twitter, oh, we want, who will write all those stupid tests that check if something returns string, etc.? And that is my favorite boss of a Twitter. He is typically great, giving best answers. This stupid library is called statically typed language. And actually, this is a law, kind of, that if you want some constant quality, you can either do more tests or more types. So if you have absolutely no types in compilation, you'd rather do a lot of tests, even stupid. If you have perfectly typed language with sophisticated type system, there is one, for instance, Idris, you can almost forget about tests. But it's hard. Okay. So is anything better in terms of the type system? For instance, you know this language, just, what is this? var, etc. What's this? No, this is Scala. You know how to recognize it? There is no semicolon at the end. This is valid Scala. Actually, this code works in Scala, in a console log, because I will show you. So Scala is a hybrid between functional and object-oriented programming. And it has this great feature, type inference, not like Java, stupid one, but you put var, and the compiler, if it's obvious, will put the type for you. So it's like you don't have to write this ceremony of the types. If it's obvious, the compiler will deduct it for you. This is like the great choice. So it's like has both positive of both sides. You don't have to write, and you have this, like eating cookie, having cookie. And this is favoring immutability, compiles to JVM, and by the way, compiles to JS, and this code actually was compiled to JavaScript. This is also Scala, Scala.js. And yeah, that's a great thing. But the problem with Scala, yeah, a lot of people say it's too complex. But it has no semicolons. You save a lot of keyboards because of that. But coming to the end, meanwhile, in the hardware happened this. Multicore processors. And with multicore processors, we've seen a lot of new bugs because software that was designed for one processor, now exposed into really working in many threads, was showing a lot of problems with sharing variables, etc., lack of synchronization, etc. So we needed another language. And this language should be easy. Of course, this is Haskell, and what's great is a functional programming language. It means everything is, by definition, immutable. That's actually not true, but it favors immutability and pure functions. It means it's easy to scale into multiple cores and then don't really share anything. So functional programming programs and languages are, by definition, quite scalable, and you can actually see it now because Haskell was designed at 1990, but it's more and more popular in just last years, after the hardware became good enough for it. Okay, so to finish it, JVM languages. This is all generically about all the hardware, but we have JVM. We are Java people, so how it looks at JVM level? Sorry, just one thing. Java has some problems. Come on, ceremony, we have it. Functional programming in Java, oh, come on, lambdas are not really all that you can have. The type system is very limited if you compare it to like Haskell or Scala. And you've already tried with var in Java 11. Is it great? But the thing is, you can have var, like Scala, but only inside of a method. You can't have it like a field or whatever. In Scala or Kotlin, you can put it everywhere. So actually, those new languages are more, I would say, better designed. They are more consistent. Java became quite inconsistent because it's like, you have this perfect greenfield project, business comes to you, I want a message board, and you do architecture for message board, and after the year they say, okay, this message board works fine, I want to sell now, I don't know, iPhones with this. And you see, oh, now I have to hack it all. That's what is happening with Java now, is hacking. And of course it works, it's great, but it's no elegant anymore. Actually, I would say this first Java, 1.2, was really elegant. There was only one stupid way of doing things. But yeah, nobody liked it. So, but to solve this, we have so many alternatives, like Groovy, like Clojure, like Scala that has everything. I'm doing for last year mostly Kotlin, which for me is Scala minus. For some people it's Java++, and it's really productive. Or there is ETA. Also, I'm a little bit involved, which is Haskell for JVM. It works great. And okay, so remember that language is syntax, semantics, library, and tools. Some languages are great, but the tools are really not mature. But there is one thing Bruce Eckel a couple of years ago told that at the Geekon. There is community. You have to, some languages are great, but the community is horrible. So, it's like you like the concept, some people say that they believe in God, but they don't like the guys that, let's say, organizers of this religion. And this is like, there are some guys that, there are some languages which are great, but the community is kind of horrible. For instance, Python is known for having a community that will help you. And Scala is, for instance, known that if you have a problem, the first answer you get, you noob, you should better learn what you are asking and not waste our precious time. Of course, that's allegiance, but I've seen this on the message boards. So, yeah. But the reasons for the languages, to sum it up, I would say the most productivity, we want to make things faster because this automates. We have a new hardware, so we have new possibilities. We have new ideas like Lisp or Haskell. We want to try them. And one very important that I put, for me it's the most important, we want less bug. We want to go on Friday to start our weekend, not fearing that there is a bug on production. For instance, a lot of these languages, like for instance, Kotlin introduces null safety. No more line-pointer exceptions. Well, of course, it doesn't really perfectly work, but it solves the problem. Or Rust language, which should solve concurrency problem. All these languages, partially solve the problems that appeared in the previous generation. The problem is that this means end of privacy for your code. What I mean? That, for instance, malloc in C is a function call. C doesn't know that you are allocating memory. That's just a function call. But in Java compiler, and the JVM knows, oh, you are allocating, maybe I should take care of the deallocating. Or synchronize it better. In C++, you can have semaphore and lock, but this is a method call. C++ doesn't know you are synchronizing, so if the exception happens inside, it doesn't know that it had to unlock it. So you have a deadlock. In Java, it knows, but you have to provide this information to the compiler. It's the same, for instance, with the Rust sharing, etc. So this is one thing. We will have a new languages because they will be fixing the bugs that we have, and they will be fixing later if the one problem like null pointer exception is solved, then we'll see, oh, now we have other bugs on the list, and we should have a new language or new feature. Of course, better productivity, that's very easy, or hardware possibilities, we have better hardware, we can use new languages, new concept, even if the concept like Haskell is based on, let's say, functional programming, lambda calculus. But now with a multicore, it actually works. And there is this cycle I can draw. We have a new hardware, so we can try new ideas, but if we have new ideas, we make new bugs that previously were kind of hard to imagine. And if we have new bugs, we put restrictions on a language, a ceremony that prevents us from these bugs. But then we have a ceremony, so someone invents something less crazy, and more productive, let's say, language concentrated on having things done. And this cycle, of course, it doesn't always go full way, but this is how I think it more or less works, and I think it will. So languages there are actually not to destroy your life, are to help you to have less bugs and be more productive. And they change the way you think. So for instance, this is a code I have in Java on a GitHub, where I had two methods that were looking totally one way. But I couldn't unify them in one. But then I was rewriting, because of other projects, this code into Haskell. In the moment I was rewriting this to Haskell, I was thinking in Haskell. While thinking in Haskell, I've seen, oh, lenses solve this problem. And then in Haskell, this was one method, but one function. But actually, the way of unifying also works in Java. But I could only see it looking from a Haskell perspective. That is how you can be better Java programmer or whatever, learning completely different language. That's what I recommend to you. And be brave. People say, we can't use something in a company. Of course, you don't learn Scala and put it in production right away. But you in a company do prototypes, do reporting tools, do a lot of stuff, do hackathons. If you are on a hackathon, have fun, learn something. It's not, actually you can be more creative in new language and maybe win the prize if you try something new. Because there will be like new things in your, that pop up in your mind. Okay. I have to finish that, and by the way, don't be afraid that some language will die. Languages rarely die, actually. If they have like thousands of developers, you will always find them. And in the future, we'll have new languages, because actually there is no good language I know at the moment that is perfectly good for artificial intelligence. Python is used there, but it is not really designed for artificial intelligence. It's just handy for processing data matrices, etc. Or a language that really uses 200 cores. I don't think Haskell is perfectly designed for that, or better uses GPU, or FPGAs. Google, what is this? Or Internet of Things. Actually, JavaScript is working there. Is this a perfect solution? I don't think so. Or better security, or language that enforces privacy. That, for instance, if you put sensitive data, its compiler guards this data. We don't have anything like that. And that's the end of my talk. We'll have new language. Good luck with that. Have fun. Remember. Thank you.